So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
Welcome to this week's Energy Show. Now, AI, or artificial intelligence, for those of you who have been under a rock for the last 5 years, it's becoming more and more capable with smart answers to all kinds of questions. And it's easier to access AI verbally and in documents and spreadsheets and things like that. So I asked AI some common questions about heat pump HVAC systems. And I was wondering about how well these computer answers compare to an expert heat pump designer. So this week's show is a roundtable between AI and our heat pump design consultant who specializes in high-performance buildings and focuses on indoor comfort issues. It's a man versus machine roundtable, like the legend of John Henry. But instead of John Henry, we have Daniel Raris to talk about our general philosophy when designing a heat pump HVAC system to replace an old natural gas furnace and air conditioner. So welcome to the show, Daniel.
Thank you, Barry. I appreciate it.
All right, so tell us a little bit about your design and system installation philosophy.
Yeah, the philosophy whenever you design a system is that it should be based off of the design of the structure that the clients or occupants are living in. It should also be based on the performance of that building, whether it's got a high leak rate, double pane windows, single pane windows, does it have an insulated roof or the walls insulated, and then the layout, and most importantly, how the clients or occupants use the house. It's really important to design that system specifically for the occupants and the structure itself.
And as an electrification contractor, we also like to understand what the electric bills are and the natural gas bills are, because if we know what your annual natural gas usage is by therm by month, we can get a really good idea of how much energy you're using for heating.
Yeah, absolutely. I mean, 29.2 kilowatt hours is equal to 1 therm. So it's a really simple conversion, plus the coefficient of the heat pump. We have a nice calculator that really can do that for us. So yeah.
Yeah. So one of the things that we do that really helps distinguish us is just by looking at natural gas bills, we can really accurately figure out how big a heat pump you need. And we're going to talk about that more, but for most systems, it's a better approach. Let's roll right into that. So I asked AI, how should I size my heat pump system? And AI says, and this is kind of the standard industry way of doing it, they say, calculate the heating and cooling load for the building and perform a manual J calculation. Now, that's correct for new construction. But for an existing building, if you do that, you're not really going to be able to consider how the building is used, how people keep the temperatures in the building throughout the year, how much ventilation is there. So new construction, do the heating load calculation or do this manual J calculation. But for retrofits, especially for people who are saying, I want to get rid of that old natural gas furnace and put in a heat pump. That's a wrong answer. The right answer is, as you pointed out, is do a calculation based on the therms that you're using to see how much energy you need for the heat pump. And then what we're doing also, because we're generally installing solar, we can then figure out how many more solar panels you're going to need to create the kilowatt hours that are necessary to actually heat your house. A much more accurate method. Okay, next question. To Mr. AI, how much maintenance is required for a heat pump HVAC system? And what AI said is a heat pump HVAC system is an efficient and versatile means of providing heating and cooling. Proper maintenance is key to ensuring its longevity and optimal performance. Maintenance includes cleaning filters and cleaning the outdoor units. So in your experience, what do people really need to do in the real world?
Yeah, I mean, the most important thing you could do with any system, whether a heat pump, furnace, whatnot, change your filters. Change your filters. You know, if you have a whole home ducted system or any type of ducted system, those are going to be paper replacement filters, whatever MERV rating you want, replace it. If you have mini splits, those are washable filters. You don't have to have paper replacements. You save yourself some money, but they do need to be washed considerably a bit more frequently than your paper filters on a whole ducted system, depending on how much you use your system, depending if you have pets, hair, how dusty your house is, in that order.
So just out of curiosity, so for the mini splits, let's say you have a ceiling cassette unit, how do you clean that filter? How do you get to that?
You know, if it's really high up on a wall, you get a ladder.
Or if you're really short like
Yeah.
me, you get a ladder.
Yeah.
Okay.
You know, that goes into the whole design consideration when you design the systems to make it easily accessible for your clients. But the filters are all located within each unit, either that or a ceiling cassette. They just pop right out, throw them under the faucet, give them a nice rinse, let them dry, and put them back.
Okay. And then if you've got a ducted system, usually there's just a filter that you slide out.
Yeah, yeah.
Okay. All right. Next question that people have. Should I get a hybrid system heat pump with natural gas? So AI says, while hybrid systems can offer long-term savings, the initial installation cost may be higher compared to traditional heating and cooling systems. And the reason is because you have both the heat pump capability and the furnace capability. But, you know, when we kind of look at these situations, that advice is kind of old. Many of the new heat pump systems work great even in very cold weather. And the purpose of having a hybrid system is you have natural gas backup. So even in Maine, they've kind of standardized on these high efficiency, low temperature heat pump systems. Nevertheless, if you're in a cold climate and you're kind of concerned about it, having natural gas backup is good. And when you look at the economics between the two, yes, it's going to be a little bit more expensive for a hybrid system. But if you have really cheap natural gas and very expensive electricity, it might make sense. Whereas here in California, we almost never, ever install hybrid systems just because the climate is so temperate. Okay, next question for Mr. AI. What is better, a mini split or a ducted system? And then AI comes back with a kind of a general answer. The choice between a mini split and a ducted system depends on various factors such as the size of your space, installation requirements, and personal preferences. Daniel, the expert, what do you say?
Yeah, I actually agree with that. You know, mini splits are great for some people and they're not for other. You know, if you're, you know, a little bit in your later years in life and you've been used to a simple thermostat and you're used to a ducted system and that's what you've been used to for the past 40 or 50 years, that's probably what you're going to want. You know, if you're a little bit younger and you know about mini splits and your whole goal is to be completely self-sufficient as possible and use the least amount of energy that's required and you want room by room temperature control, then mini splits are the way to go. It's really going to be dependent on the client themselves, the mode of operations they want, and ultimately their energy efficiency goals.
Does it depend on the size of the home?
All the mini splits come in different sizes per room. So, you know, it's not like you're just using one mini split for the whole house, right? It's a room by room installation. So it depends on the size of the room that they're trying to heat or cool.
And then financially, how do they compare for the same house?
If you're doing a large, you know, house with, let's say, 8 to 7 mini split units, 7 or 8 mini splits, compared to a traditional ducted system that has 10 or 11 supplies, believe it or not, it runs around the same price within the difference of probably $3,000 to $4,000. So it's not a huge difference.
And you get much better control.
Yes.
Except
absolutely.
you got to keep track of those little remote controls.
Yeah.
It falls in bed.
Or you can control it with an app.
They have apps, of course, right, naturally. All right. Next question to Mr. or Ms. AI. How much money will I save with a heat pump? And AI says it depends on several factors, including the type of heat pump, your current heating and cooling costs, and the climate in which you live. So very specifically here, heat pumps save money in mild climates and in areas where electricity is cheap compared to natural gas. You're going to get the best savings, even better savings, and this is what we're experiencing here in California, in mild climates when you get your electricity from rooftop solar. Then heat pumps make a lot of sense. It's absolutely a no-brainer here in California, Florida, Texas. If you have solar, heat pumps make a ton of sense. But the trick about it is when you're planning on installing solar, it's important to know how many extra solar panels you're going to need for that heat pump. Bottom line, in colder climates, depending on the price ratio of electricity and natural gas, heat pumps can be slightly more expensive to operate than your traditional pure natural gas furnace. But heat pumps pretty much always give you better comfort and clearly they're safer. Okay, next question. Do I need a building permit to install a heat pump system? And Ms. AI says, yes, you will likely need a building permit to install a heat pump system.
Yeah, it's always recommended to have a building permit. You know, if you're doing a like for like type of installation though, you know, and you want the condensing unit in the same place and you want on the side of the house, you know, then maybe not. Mm-hmm. At that point, codes could have changed where now you need it in the backyard space that you want to use and it won't meet the setback requirements. So it could be really up to the homeowner and the contractor doing the job.
And we're experiencing here, especially with all the incentives, there's tax credits, there's rebates, there's state incentives or local incentives. You pretty much always require a signed off building permit in order to get those incentives. And the other advantage of getting a building permit is you're going to have some confidence that the system was installed to code and safe.
Yeah.
All right, next question. How good a job does a heat pump do with dehumidification? So Ms. AI says, the size and capacity of the heat pump relative to the space it is servicing plays a crucial role. An appropriately sized heat pump can effectively maintain desired humidity levels, whereas an oversized unit may cycle on and off too frequently, leading to less effective dehumidification. So I've been in communication with my good friend Nate Adams. He's like the house whisperer. He's an expert on retrofitting heat pumps and making sure that homes are comfortable. And basically his point is heat pumps generally don't do a great job with dehumidification. Now, dehumidification isn't a big deal here in California, but in other climates it does make sense. He points out that heat pumps do a great job of temperature control, but not so good at dehumidification, especially in the fall and the spring, because to dehumidify, the systems must run kind of slowly for extended periods of time at a very low cooling output. But most heat pump HVAC systems can't turn down to much less than 25%, so they're cooling the room down much faster than they're dehumidifying. So you end up with rooms that cycle up and down, hot, cold, or you end up with muggy rooms. So the best solution is a separate dehumidifier or a reheat system. All right, next question. What's the hardest part in retrofitting a heat pump system? AI says retrofitting a heat pump system presents several challenges that require careful planning, evaluation, and execution. I'm going to flip this one right over to Daniel because he's been through this, putting on the mask and the gloves and the suit to crawl around. So Daniel, what are the challenges?
Yeah, I think that the largest challenge is if you're coming from a traditional ducted system and you think you could just swap out for a heat pump, the blower motors and air handler work completely differently than in the furnace. And so you could end up with hot zones, cold zones. If you already don't have them, could be exaggerated by the way the blower motor is working. The ducts generally shouldn't be replaced unless they're brand new. Generally, they're older. And then once again, it's doing the right thing with the clients and how they use their house. Design that system for the house, for the clients, and give them the options that allow them to do that.
So let's drill down on that a little bit more. When you get to a customer's, 30-year-old house, 40-year-old house, and they have some ductwork, whatever, where do you go in the house? What do you have to crawl around and determine to see what the right design is?
So the first thing I like to do is to ask permission to just walk all through the house. I want to kind of get a lay of the land. I like to see what does their family room look like? What does their kitchen look like? What does the living room look like? What does the dining room look like? Do these rooms look like they're used a lot? How do the clients use this room, right? As I'm looking at the windows, I'm looking at the walls. I'm asking if the wall's been insulated. What year was the house built? Here in California, it wasn't code till 1970 to insulate walls. Let's say the house was built in 1972. Is that insulation really doing much now today? Probably not, right? So there's a lot of contributing factors here that I'm asking the clients and looking while I'm making this thorough walkthrough with the house with the clients. At that point, once the thorough walkthrough is done, I have some good guidelines of what I see in my head it would be done. Where's the current system located? Is it a downflow? Is it an upflow? Is it a two-story home? Generally in a two-story home, we have a really hot upstairs. That's where all the bedrooms are. And the downstairs is cold, right? So they want to blast the AC. They freeze the downstairs to get the temperature of the upstairs properly. And at that point, it's sitting down with the clients and talking about design considerations. Okay, what stage of life are you? You're a kid small? Do you have teenagers? Are your kids going to college? Are you empty nesters? How would you want to design this house? Where are you primarily spending most of the time? Where do we want to focus the energy and your money on the heating and cooling of the home?
So how do you figure out what do you have to install in the attic or the crawl space? I remember for my house, 2-story house, and there was stuff installed in the attic. There was equipment installed in the crawl space with new ductwork. How do you evaluate that?
Yeah, it's really based on the client's needs. Let's say you have a 2-story home like yourself, you have ducts in the crawl space. It was a downflow unit. Now with heat pumps, you could do either a double ducted system, one duct system up for the attic, and that's strictly up for the upstairs, one that's strictly down for the downstairs. You have two completely independent zones off of one condensing unit. Now, in the summertime, if it's not too hot out, you can shut down the bottom unit, and then the upstairs, you have the air conditioning on, so you're not freezing the downstairs, but you have that nice cool temperature when you go to bed in the evening. You could do mini splits upstairs for the bedrooms. You could do a ducted system for the downstairs. It tells about how much room is in the crawl space. It's not code for the ducts to be laying on the floor. So, it depends how deep it is. If there's room there.
Do you have to crawl into the crawl space and climb, poke your head up into the attic?
Oh, always in the attic. I'm a pretty big guy. You can't see on this podcast. Some crawl spaces I just don't fit into, but I always take a peek. Always, I can't tell you how many times I've opened a door to a crawl space and there's the original ducts from the 1960s covered in asbestos. They got to be removed. Can't deal with it. So.
And what do you do about the asbestos?
Under California law, it has to be done by a certified asbestos company. So that goes in part of the design considerations of proposal.
Yeah, no, we've been through that. I went through that with my house. And then as a contractor, if there's fewer than 100 square feet of asbestos installation, the contractor can remove that himself.
Yes.
Which typically happens on the flue from the old furnace.
Yes, the plenum box or something like that.
But if it's, a lot of duct work, I had a really, really old house that started off with a coal boiler and all the pipes under the house were covered with asbestos. Okay. All right, well, we're almost done, but to wrap up, what are the most important considerations when designing and installing the best heat pump system for your home? I'm not even going to ask AI. I'm just going to ask Daniel.
Yeah, I think the most important thing is considering what's right for you and your family. If you're a client and you're looking at upgrading to a heat pump from a gas furnace, really take your time. Do not wait for your furnace to just go out and then be like, oh my God, I need to get a replacement. It's just like if you're going to buy a car, if you're going to remodel your kitchen, you're going to remodel your house, you're going to take your time in designing exactly what you want. This is the way an HVAC system should be looked at. Get a contractor who knows what they're doing, who has a background in heating and cooling and building science, and can go into your house, educate you about the best way to design a heating and cooling system specifically for your home and the way you operate it.
All right, good advice. And, since it's so qualitative and specific, AI does a great job for the objective answers, but when it comes down to circumstances at a particular house, there's no substitute for an experienced designer. All right, that's all the time we have on this week's Energy Show. Thanks, Daniel, for joining us. What a designer like you is never going to be replaced by a computer. Now,
Absolutely.
I hope I can say the same thing about podcast hosts. Anyway, thanks to all of our listeners for tuning in. And if you missed any of today's show, you can always go to the Energy Show website at energyshow.biz and listen to the podcast.
Thanks for tuning in to this week's Energy Show.